last lecture I have told you some points for this underinforced section, overinforced section, and then balance section. Okay, so simple stress strain diagram I will draw once again for you. Okay, so that it will be recalled for you. Simple for the singly reinforced beam we used to draw the stress strain diagram. Okay, that diagram I will draw once again so that it will be helpful to you to recall some formulas and points. So this is the cross section of the beam. Then I will draw the neutral axis. So suppose this is our neutral axis. This is neutral axis. I will write here NA, neutral axis. Okay. So this, then B is the width of the beam. Okay, and capital D is the overall depth of the beam. So width of the beam is B. So here it is B, width of the beam, and this total is the capital D, that is overall depth of the beam. Now you are familiar with the terms, what is effective depth and what is overall depth. I think these concepts are clear. Okay. Now a reinforcement is placed in the beam. So here the reinforcement, suppose these are the reinforcing bars. This is the singly reinforced beam, so only at the tension side reinforcement is provided. You know that in the case of doubly reinforced beam, we provide the reinforcement on tension side as well as on compression side. So on the both the sides we provide the steel in doubly reinforced sections. But for the singly reinforced sections, we provide the reinforcement at the tension side only. Okay. So now I will project this line for to draw the strain diagram. Okay, and this will also require to show the tensile force. So I will project this. Okay, now first of all we will draw the strain diagram. Okay, so to draw the strain diagram from here, this will be our strain diagram. Stress is at the top and the tensile strain is at the bottom, compressive strain is at the top. So at the top this is the compressive strain, at bottom this is your tensile strain. Okay, and you can join these two lines. Okay, so these two lines can be joined. So this is the maximum compressive strain, it is 0.0035. This is the strain distribution I am showing to you. This is the maximum compressive strain. And what is the maximum tensile strain? As you know that to calculate the strain, what is the formula to calculate the strain? Strain is nothing but stress upon Young's modulus. So what is the stress in steel? Now this is at this level. Okay, so what is the stress in steel? The stress in steel is 0.87 Fy divided by what is Young's modulus of steel? Es is the Young's modulus of steel plus 0.002. Okay, this is for torr steel. If the torr steel is used, then plus 0.002. I have already explained you while taught you the graphs. We have seen the graphs of mild steel as well as for torr steel. Okay, at that time I have told you this strain. So this is your maximum tensile strain. Okay, and now if you go for the stress distribution diagram, this is your strain distribution diagram. Then stress distribution diagram, again the diagram will be same. Okay, so here then this is your tensile force at this level. Okay, here it is your tensile force. Then if you draw the diagram, it will be, this is the stress 0.446 FCK. Then it is straight line up to the strain of 0.002, it is straight, and from there now from here onwards it is parabolic. It is like this. Okay, it's parabolic. And now if you project this, see, if I project this to here, I will project this point. Okay, here this point, if you project to this strain diagram, so here at this point, so here this at this point here your strain is 0.002. Your strain is 0.00, and your compressive force is acting just above this. Here it will act. Okay, this is your Cu, you know that this is Cu, this force is Tu. Tu is equal to what? It is 0.87 Fy into AST. This is your Tu. What is Cu? Cu is equal to, you know that, 0.36 FCK B into XU. This is the value of Cu, and the distance between Cu and Tu, it is called as the lever arm. Okay, so this distance between these two forces, it is called as Z, that is lever arm. It is D minus 0.42 XU. Okay, so how it comes? So you know that this distance is, this is how much this is 0.42 XU. Okay, and now effective depth. So this will be the effective depth. This is your small d. This is your effective depth, small d. Okay, up to this point here, from top up to this point, this is nothing but this is your effective depth, and from top to bottom it will be your overall depth. Okay, you know all these things. So this is the basic diagram of the singly reinforced section. You know that for the doubly reinforced section, what will be the change? Here we provide the compression reinforcement. Then here two forces are there. First is Cu1, second is Cu2. Cu2 will act at a distance of d dash, where d dash is the cover in compression. Where we show the reinforcement, we left some cover from the top. Okay, and the distance between then Tu and Cu2 is d minus d dash, that is the lever arm. This also we have seen in DCS. Okay, so this information I have given to you for just to recollect and rebrush. Also you should know the various Mu limiting values for the different types of grades. Here in short I will tell you. Here the grade of steel. Okay, grade of steel. Then XU max by D ratio, this is also given in IS code. And then Mu limiting, I have marked here three tables. Okay, if you want you can take these values. These are important values which frequently required. Okay, so here now first grade of steel. So if Fe250 is there, Fe250, what is the ratio XU max by D? It is 0.53. This is also given in IS code. And what is the Mu limiting? That is moment of resistance 0.148 FCK BD square. This formula is also we have used quite several times. Then for Fe415, it is 0.48. That is 0.48. And what is the Mu? It is 0.138 FCK BD square. Okay. Then Fe500, it is 0.46. You know that it is 0.46. And what is Mu limiting? It is 0.133 FCK BD square. If you want you can write or you can take the screenshot of this so that we can move further. Is it over? Yes, no, you can tell me so that I will take the next slide and then we will move to the next part. Next is now the formulas are there. You know how to calculate the percentage of the steel, that way also we have covered. Then you know we always take the effective cover. Okay, so effective cover in mild exposure, now in normal conditions we take 25 mm, in moderate conditions we take 30 mm, in severe condition we take 45 mm, in very severe condition the cover is 50 mm, and in extreme condition it is 75 mm. Okay, CA. This is I am giving as per IS 456 2000. See, this is very important. Please write it down. This can be asked in the examination. हे विचारतात बरं का एक्झामला मधना क्वेश्चन असतो. So for what I am writing, please see it and take down it carefully. For different exposure conditions. Okay, for different exposure conditions. So depending upon the exposure conditions, the nominal cover as per IS 456 2000, this is also given in IS code, is okay. What IS code says, for mild exposure, okay, for if the exposure is mild, then cover must be 25 mm. Okay, if the exposure is mild. Then for moderate exposure, it is 30 mm. Then for severe exposure, it is 45 mm. This is the cover. For very severe exposure, it is 50 mm. Okay, and for extreme exposure, it is 75 mm. So any of this can be asked in the MCQ questions. ते विचारलं जाऊ शकते तुम्हाला. For the singly or doubly reinforced sections under extreme conditions, the nominal cover provided as per IS 456 2000 is dash dash dash. Then out of these four options will be given to you, so you need to choose the correct answer. Okay, for any of these what we can say, questions or answers. And the cover requirements, see, the cover requirements is depending upon the durability requirement. Okay, cover it is provided to have the proper bond between concrete and steel, and also to protect the reinforcement against corrosion. Why we provide the cover? Cover is provided first of all for what? For the proper bond between concrete and steel. And the second thing is to protect the reinforcement against corrosion. Okay. So these are some important points here. Now we will start with the questions based on this. So I will write the question, I will give you the option, and please do reply and try to give the answers of the questions. Don't sit idle. Hmm? Okay, so the question is, first question, the centroid of the centroid of compressive force from from the extreme compression fiber in limit state design lies at a distance of, and your options are option A 0.367 XU. Option B 0.416 XU. Option C 0.446 XU. Option D 0.573 XU. So I will read the question. The center of compressive force from the extreme compression fiber. So what is the center of the compressive force from the top, they have asked you, and the options, these are the options given to you. So let me know the answer. What will be the correct answer of this question? What is the correct answer? Answer is B, correct. Answer is this, B. 0.416 XU means 0.42 XU. Here 6, so we can increase this digit by 1. So we take it as 0.42 XU, and in exact figure it is 0.416 XU. Okay, so this is the answer. So in next question, in limit state design, in limit state design of concrete for flexure, the area of stress block the area of stress block is taken as A 0.36 FCK into XU, B 0.41 FCK into XU, C 0.446 FCK into XU, D 0.53 FCK into XU. Think on this and give me the answer. In the limit state design of concrete for flexure, the area of the stress block is taken as while teaching the DCS1 in first lecture in first unit, I have told you this. This derivation is there in your book. Answer is A, correct. So the answer of this question is A, 136 FCK into XU. Okay. So the next question. In limit state design, the limiting value of depth of neutral axis NA for M15 and Fe250 is Option A 0.53D, option B 0.48D, option C 0.46D, option D it is 0.43D. Now read the question and let me know the answer. Question I will read once again. Still, in limit state design, the limiting value of depth of neutral axis for M15 concrete and Fe250 steel is, and four options are given in front of you. You need to choose the correct option. So answer is 0.53D, correct. So answer is 0.53D. This is the correct answer. So for Fe250, just now I have given you the table for Fe250, 415, 500. Accordingly, you need to choose the value. So next question. The lever arm in limit state design is, so your options are A D minus 0.446 XU, B D minus 0.87 XU, C D minus 0.36 XU, D D minus 0.416 XU. So the lever arm, give me the correct answer of this. Answer is D, okay. Correct, D minus 0.42 XU. This is the answer. This is the correct answer. Okay. Now we will move to the next question. Next question is XU by D. XU by D is is greater is greater than the limiting value of section is designed as a under reinforced section, B over reinforced section, C redesigned, D balanced section. Okay, so the question is XU by D is greater than the limiting value of the section. Okay, so XU by D ratio means it is indirectly they are saying to you that XU is greater than XU max. Okay, then the section is designed as. What is the answer? Answer is option C is the correct answer, redesign. Okay, we have to redesign the section. We cannot design the over-enforced section. See, xu by d is greater than the limiting value means what? Your xu is greater than xu max, and when your xu is greater than xu max, it is your over-enforced section. And we avoid to design the over-enforced section. We redesign the section instead of designing over-enforced section. We redesign the section. So this is the answer. Okay, this is the answer. So the next question is, next question, in coastal region, in coastal region, minimum grade of concrete, minimum grade of concrete for RCC, is as per IS 456-2000. So option A is M15, B M20, C M25, D M30. What is the answer of this? Coastal region minimum grade of concrete as per IS 456-2000. In coastal region, minimum grade of concrete for RCC as per IS 456-2000. Coastal region means sea coast. What is the answer? M20. Any other answer? See, for water tank minimum grade is M20. For coastal region it is M30. Okay. For water tank, if the same question is there, minimum grade of concrete for RCC water tank. Okay, if this type of question is there, then your answer must be M20, and for coastal region it is M30. Okay? So remember this. Next, if the value of xu by d is less than limiting value limiting value then MR is given by moment of resistance MR is given by option A. MR is equal to 0.87 AST upon FCK into D minus 0.446 XU. This is the first. Second option, MR is equal to 0.87 FCK upon Fy D minus 0.446 XU. Option C, MR is equal to 0.87 Fy AST D minus 0.416 XU. The final option is MR is equal to 0.36 Fy AST D minus 0.416 XU. So see the formula for moment of resistance and let me know the answer of this. If the value of XU by D is less than the limiting value, so the answer is C. Okay, correct answer. Okay, answer is C. 0.87 Fy into AST. So MR is basically what? MR, this is T into Z when X is less than X max. Okay, so here if you T into Z, T is nothing but 0.87 FYAST. This is your value of T. And what is Z? Z is D minus 0.42 XU. This is your Z. So 0.42 means 416. Okay. So this is the answer of this question. Good. And now we will take the next question. Okay. So in limit state design, of concrete structures, the strain distribution is assumed to be the strain distribution is assumed to be. Okay. So first option is linear, second option is non-linear, third option parabolic, fourth option parabolic and rectangular. Parabolic and rectangular. And this question is asked for IES exam. Okay, in IES exam this question is asked. So in limit state design of concrete structures, the strain distribution is assumed to be. So you think on this and after thinking by some logic give me the answer. Question is very easy if you understood the concept. So answer D, parabolic and rectangular. Okay. So roll number 2 has given me that answer is D. Any other option? See how the strain distribution is there? Just we have draw the diagram, no? Strain distribution कसा असतं याच्यात? How the strain distribution is? This is the strain distribution diagram. Uh, this is the strain distribution diagram. You can find out the strain at any point. Okay, हे तुमचं maximum असते 0.0035. Here it is 0.87 Fy upon Es plus 0.002. This is the strain. Parabolic and rectangular is your stress distribution diagram. ही जी diagram आहे तुमची rectangular and then it is parabolic. This is your stress distribution diagram. Okay, and this is your strain distribution diagram. They have asked us for the strain. So parabolic and rectangular variation is for stress. Okay, for strain it is linear. Okay, this is the linear. Is it clear? Okay, for strain it is linear variation is there. For stress you can say that this part is parabolic, okay, and this part is rectangular. It is for stress. Is it clear? So option D वाटते आपल्याला करेक्ट आहे, पण ऑप्शन डी हे स्ट्रेस साठी आहे. दिस इज फॉर द स्ट्रेस डिस्ट्रीब्यूशन डायग्राम and question they ask us strain. Okay, so please read the questions carefully. So now it is non-linear. Next question. Okay, so now this question is two times asked in IES 95 also and in IES 96 also. But in IES exam this question is asked. So if FCU and FY are the compressive strength of concrete and yield stress of steel respectively and and es yes is Young's modulus of steel. So for all grades of concrete comma, the ultimate flexure strain in concrete can be taken as. Okay, so I will read the question first. If FCU, okay, if FCU and Fy are compressive strength, so FCU is the compressive strength and Fy is the what? Fy is the yield stress, कुणाचा स्टीलचा. Okay, and FCU is the compressive strength of concrete, Fy is the yield stress of steel. ES is the Young's modulus of steel. Okay, so ES is the Young's modulus of steel. So what they have asked, for all grades of concrete, the ultimate flexure strain in concrete. Okay, so what is the ultimate flexure strain in concrete? They have asked us. So the options are, A, it is a 0.002. B, it is FCU divided by 1000. C, 0.0035. C is 0.0035 and D, it is 0.87 Fy upon ES plus 0.002. Flexure strain means bending strain. Okay, axial load is also there and bending load is also there. Then this type of strain gets developed. What is its value? Answer is D. Why it is D? They have asked us the ultimate means maximum. Now answer is C. A. So झालं A काय आन्सर दिलं, C दिलं, D दिलं, मग राहिला काय फक्त B. B हे आन्सर नाहीच आहे ते बघूनच कळतंय. Okay, so answer is in between A, C and D. Okay, so ultimate flexure strain is nothing but it is the strain which is due to the axial load as well as due to the bending. Okay, now remember one thing, for axial load this is the strain. Okay, only for axial load, no bending is there, no bending stress. Okay, this is the maximum value. When no bending stress is there, this is the maximum value, and this is the maximum value when axial is also there plus bending stress is also there. Bending stress is also there. So your answer must be 0.005. They have asked us the ultimate. Okay, so this is the maximum 0.0035. So the next question. Okay, so this is from IS 456 standard question. IS 456 permits permits the maximum distribution of maximum distribution of dash dash of moments. Option A is 15%, option B is 25%, option C is 30%, and option D is 45%. See the question and give the answer. IS 456 permits the maximum distribution of dash dash percent of the moments. So while distributing the moment according to the IS 456, how much should be the permissible distribution percentage limit? See in the IS code. If you don't know the answer, please see in the IS code. गेटच्या एक्झामला किंवा कॉम्पिटिटिव्ह एक्झामला तर तुम्हाला IS code is also not allowed for that. So you should know all these clause and all these things. See 30%. Okay. Have you see this roll number 34? Have you seen this in the IS code or you have Googled the question? Because in IS code it is very difficult to find where it is given on which page and clause. That is why I have asked, because the answer is correct. 30% is the answer. This is given in the IS code. Okay. Okay. The next question is, in RCC beam of breadth B, and overall depth D exceeding exceeding 750 mm side face, exceeding 750 mm, comma, side face reinforcement, side face reinforcement required required and and allowable area of maximum tension reinforcement reinforcement shall be respectively. First of all, I will write the options, then I will read the question for you. It is 0.2% and 0.02 BD. Option B is 0.3% and 0.03 BD. Option C, it is 0.1% and 0.04 BD. And option D, it is 0.4% and 0.01 BD. So now I will read the question for you. In a RCC beam of width B and overall depth D. So width and depth is given exceeding 750 mm. So see, when the depth of the beam exceeds than the 750 mm, then on the side of the beam you have to provide some reinforcement. Side reinforcement also. Normally for the beam we provide bottom reinforcement. So at bottom we provide the steel bars. At top also we provide the steel bars, and in between we provide the stirrups. Okay. But when the depth of the beam is increased by up to 750 mm or beyond 750 mm, then we need to provide the side reinforcement for the beam. Okay, so on the side also you need to provide the bars, steel bars. So that side reinforcement required, that you need to calculate what is the side reinforcement required, and also allowable area of maximum tension reinforcement. So what should be the maximum tension reinforcement that can be provided? So the various options are given to you. So from these options you need to choose the correct answer, and it is given in IS code. This is the question purely taken from the IS code. This is given in the IS code very clearly. How much should be the side reinforcement? If you know how much is the side reinforcement, then your answer is clear, because here if you see 0.1%, 0.2, 0.3, 0.4, this is the side reinforcement percentage. If you know the side reinforcement, automatically you will get the second answer, allowable area. So the answer is C, 0.1% and 0.04 D. Okay. So 0.1% and 0.04 D. So those who are not knowing, I will tell you, side reinforcement is 0.1% of gross area. Okay. So it is 0.1% of gross. Okay. So now the next question, last question we will take for today, and very simple question is there. The limiting moment of resistance of a singly reinforced rectangular beam with M20 concrete and HYSD steel of grade Fe415 is option A 1.498 BD square. Option B, 2.67 BD square. Option C, 2.996 BD square. Option D, 2.776 BD square. So the question is the limiting moment of resistance for a singly reinforced rectangular beam. So MR you need to find out for M20 concrete and HYSD Fe415. So what is the answer? Hmm. What is the answer? It is very easy. See, I will tell you. Why it is taken so much time? For easy questions you are taking so much time, and for difficult questions you are giving the answer in just a minute. Okay. Answer is C. No, no, C is not the answer. See here. What is the grade of concrete? M20. And Fe415 is the grade of steel. For M20 and Fe415, we know the formula for Fe415. What is the formula for MR? It is 0.138 FCK BD square, right? So here if I put MR is equal to 0.138 as it is, multiplied by FCK, M20 is given, multiplied by 20 into BD square as it is. So if you multiply 0.138 by 20, then you will get it as a MR is equal to what? It is 2.77 BD square. So your option is D. Okay, so that's so much simple question is there. If you want, you can take the screenshot of this. Okay, so today for today's now we will stop over here. These are some questions on singly reinforced sections. In the next lecture we will go for doubly reinforced sections also, and after that if time is there then we will go for T section, L section and our continuous sections. Okay, whatever may be there in syllabus. If it is not there in syllabus continuous beams, then we will go for pre-stressed concrete. Okay, so for today now we will stop over here. Okay, drop your roll number into the chat box and by in proper format please, otherwise you will be responsible for your absentee. Write your division first in capital letter A or B, then give space, single space, double space टाकू नका, single space द्या मध्ये आणि roll number लिहा.